And so now this is where we can kind of piece together the implications and think about performance and those kind of things. So to understand this, we kind of have to go over static catalogs and what the difference between the static file content and file content APIs are. So if you're on a new enough version of Puppet Server, you'll get these extra metrics at the end of the line here in the access logs. And what this shows us is the duration of the request, the size of the return request. I forget exactly what. But the most important is the last one, which is the number of milliseconds we borrowed a JRuby to fulfill this request. And so we'll go over that very quickly. A JRuby is essentially the concurrency bandwidth available to Puppet Server. So if we have, say, 4 of these on our Puppet Master, we can do 4 things simultaneously, like serving catalogs, compiling catalogs, anything that populates this will borrow a JRuby. There's a lot of things that do this. And we don't need to completely understand how this works, which is great because I really don't know. Ask someone in engineering who wrote that. But for our purposes, we can see that this file content API had to borrow a JRuby for a certain amount of time to fulfill this request. And what that means for us is that we've used some of our concurrency bandwidth of our compilers and master to do this. And if we were to go back through, so the static file content API, you'll notice the last column is blank. So that means that we did not have to use a JRuby to fulfill this request. And again, I don't know exactly why that is or the code behind it that accomplishes this, but the takeaway is just that we didn't have to use a JRuby for this. And that's because these are part of what's called static catalogs in Puppet. So also with this approach, we didn't have to individually check the metadata of the file, and we served it statically. So we can look at the documentation for this real quick. This is the static catalog documentation for Puppet. And I would encourage everyone listening to go through and read this. But for this purpose, we can just look at part of this real quickly. So the important part for this is this paragraph right here. So each time a Puppet agent applies a non-static cache catalog that contains file resources sourced from Puppet URIs, the agent requests file metadata from the master even though nothing's changed in the cache catalog. This causes the master to perform unnecessary resource-intensive checksum calculations for each such file resource. Static catalogs avoid these problems by including metadata that refers to a specific version of the resource's file. So the takeaway from that is when you're using static catalogs, we know what the version of the file is. We don't have to check. So if we look at what was going on during these logs, the other files are still under management, but we don't have to check the file metadata for them because we know what it is. Until we do a code deployment, it's not going to change, so we don't have to check it. But we did have to do this for the file server mount, because it's not part of a static catalog. That's just a location on disk. We don't know when that changes, so we have to check it every time. So every subsequent run, we'll still have to do this. Well, that's file content, sorry, file metadata here. We'll have to do this check every time. So now if we start thinking about that at scale, what if this file were larger, say a megabyte or something, and we have 10,000 agents checking in every 30 minutes. That's 48 times a day, times every file that you're serving this way. The implications ramp up quite a bit at scale. And so this is something that you may not notice when you don't have that many agents, or maybe you just have enough network bandwidth to get away with this for a while. But I have seen cases where serving files this way can really tank performance. And there's a couple of factors that could also make this worse. So the first one I mentioned is larger files, right? So in order to do the checksum on the file, we read it into memory in chunks and then run MD5 sum on it. So if the file is larger, then that obviously takes more time. But the second factor is an evil so unspeakably terrible that I won't demonstrate it, is if you have the source of these be an NFS mount. So in that case, you have to send the content of the file over the network to the master or compiler so that it can check the metadata. And thinking about those things at scale again, you could be sending, gigabytes of data over the network just to check metadata for files that probably aren't changing that often, right? And the most common situation I've seen this in is managing Windows binaries and installers and things like that. People will put them on an NFS mount and serve them this way. So if anyone listening is doing that, don't feel bad. It's definitely been done before. And personally, I think that's because Windows waited until 2020 to think about having a package manager and things like that. So those are the demonstrations that I wanted to perform today.